Up until this point, we've discussed the relationship with nutrition, specifically the nutrients in food, and how they're related to growth, development, aging, as well as chronic disease. Now we're going to take a look at food in a different way and review some of the compounds which are added intentionally, sometimes unintentionally, as well as those which occur naturally. Being aware of what's in the foods we're selecting is another step towards good health. The FDA, or the Food and Drug Administration, is often referred to as a watchdog agency. It helps protect consumers from unsafe foods and drugs and focuses on the following concerns: foodborne illnesses, nutritional adequacy of foods, environmental contaminants, naturally occurring toxicants, pesticides, food additives, as well as water safety. We'll discuss some of these topics in more detail and hopefully help you as consumers be able to make informed food choices. The first topic we'll look at, which is designated as the FDA's leading safety concern, include foodborne illnesses. Outbreaks of foodborne illnesses, or commonly known as food poisoning, outnumbers any other food contamination. It's estimated that about 48 million of people in the United States each year become ill through this route. Those who are most likely to become ill are pregnant women, children, the elderly, the chronically ill, as well as the malnourished. The good news is that most foodborne illnesses can be prevented by storing and cooking foods at their proper temperatures and preparing them under what we would refer to as sanitary conditions. There are two foodborne illness classifications: infections and intoxications. First, we'll look at the foodborne infections. One becomes ill by eating foods which contain these infectious microbes. And in the United States, the three most common include Campylobacteriosis, Salmonella, and E. coli. The microbe Campylobacteriosis is found predominantly in raw and undercooked poultry, as well as meat and fish, unpasteurized milk, and contaminated water. It may often be hard to identify this particular microbe with a particular food making you sick because it may take up to 2 to 5 days for symptoms to occur. Typical symptoms are generally GI related: diarrhea, vomiting, cramping, and there can also be a low-grade fever associated with this particular foodborne microorganism. Salmonella can be present in raw or undercooked eggs, meats, and poultry. Unpasteurized milk, shrimp, as well as yeast can also harbor this particular microorganism. Symptoms appear a bit quicker than with Campylobacteriosis, usually about 1 to 3 days after ingestion. The symptoms are also GI-based, including nausea, vomiting, and diarrhea, with a possible fever. E. coli may be found in unpasteurized milk, apple cider, or juices, raw or undercooked ground beef, as well as raw fruits and vegetables, and raw dough. The time period for symptoms to appear vary greatly, anywhere from 1 to 8 days after eating. The appearance of bloody diarrhea, as well as severe cramping and vomiting, are present, and if not identified and treated, may lead to kidney failure. The other classification of foodborne illness includes intoxications. In these cases, the illness is caused either by the food containing natural toxins or by a microbe producing a toxin. Staphylococcus aureus produces a toxin and may be present in meats, poultry, and eggs, as well as in tuna, potato, and macaroni salad. Cream-filled pastries may also harbor this particular microorganism. The onset of symptoms is very quick with Staphylococcus aureus, usually producing GI effects within 1 to 6 hours after ingestion. Clostridium botulinum causes a condition known as botulism, which again is due to the production of a toxin. This microbe is predominantly found in an anaerobic environment, meaning that oxygen is not present. It's in an anaerobic environment of foods that are low acidity. So the foods which tend to have a higher possibility to harbor Clostridium botulinum include canned versions of mushrooms, beans, corn, asparagus, chicken, tuna, and meats. Symptoms usually appear quickly within 4 to 36 hours after ingestion and include double vision, swallowing, and speech difficulty, leading to possible paralysis of the respiratory system. So it can actually be fatal in some situations. There are prevention methods recommended to decrease exposure to potential foodborne illnesses. They include cooking meat to appropriate temperatures, using sanitary food handling methods. One should wash hands often when touching food, as well as washing utensils and counters with hot soapy water. Avoid cross-contamination. This refers to contamination of food by bacteria that occurs when it comes in contact with surfaces previously touched by raw meat, poultry, or fish. An example of cross-contamination would be slicing tomatoes on a cutting board that previously was used to prepare chicken. The bacteria in the chicken transfers to the tomatoes, increasing the risk of food poisoning. Other recommendations include avoiding unpasteurized milk and juices, refrigerating foods promptly, thawing foods in the refrigerator or the microwave, as opposed to letting it thaw on a counter for several hours. If there's just one microbe present in a food, it will increase exponentially at room temperature as it sits there thawing. Avoid cans and containers which are dented, bulging, leaking, or have leaky seals. The potential for exposure to microbes is high. One prevention method I just noted was cooking meats to a proper temperature. It's also important, however, to keep other hot foods hot by reaching certain temperatures to kill microbes and prevent bacterial growth. This particular slide shows the recommended temperatures for various foods, again to reduce exposure to potential illnesses caused by microbes themselves. Another concern of the FDA are environmental contaminants. The concern about environmental contamination has increased due to a growing population as well as industrialization. Contaminants are defined as substances that make a food impure and unsuitable for ingestion. There are many ways we can be exposed to contaminants. Industries pollute the air, water, and soil. Plants absorb the contaminants. Fish and seafood are exposed to contaminated water. We eat these foods directly, or we eat livestock such as cattle, poultry, pork, etc. that have eaten contaminated plants or may have been ingesting contaminated water. Contaminants find their way into our bodies and then have the potential to cause health issues. Not only the FDA monitors contamination exposure, but the EPA, or Environmental Protection Agency, also plays an important role. The potential harmfulness of a contaminant depends on if it has a short life or a long life. Those that are short-lived can be broken down by microbes, sunlight, as well as oxygen. Others, the body can excrete or metabolize to harmless compounds. Others, however, have a long life and they resist breakdown and can accumulate in the body. Each level of the food chain then has a greater concentration than the one below it. This is known as bioaccumulation, which by definition refers to the accumulation of contaminants in the flesh of animals high on the food chain. This figure depicts an example of bioaccumulation in seafood in relation to the food chain. Plants and plankton at the bottom of the food chain become contaminated. Contaminants then become more concentrated at every level of the food chain above it. Since humans sit at the very top of the food chain, the concentration of contaminants is therefore at the highest. One example of a harmful environmental contaminant is mercury. Industries have been found to illegally discharge mercury into the water, and fish become contaminated. When the fish is then consumed, mercury contamination in humans can result in blindness, deafness, coordination issues, diminished intellect, and even death. Infants born to pregnant women who consume foods that are high in mercury can also be greatly affected. Fish noted to be high in mercury include tilefish, swordfish, king mackerel, and shark. Those that are low in mercury include cod, haddock, pollock, salmon, sole, and tilapia. We often think that eating natural foods will reduce exposure to substances which may have adverse health effects. There are, however, natural foods that contain toxicants. While actual harm rarely occurs, the potential for adverse effects is still present. Some examples include lima beans and fruit seeds. Now, these are fruit seeds such as apricot or peach pits. These contain cyanogens, which are inactive compounds that produce cyanide, which can be a deadly compound. Now, we don't eat fruit seeds, so exposure from those is rare. One would also need to consume enormous quantities of lima beans, but again, there is a natural toxicant present to note. Certain vegetables contain goitrogens, compounds which enlarge the thyroid gland. These include cabbage, bok choy, turnips, kale, Brussels sprouts, cauliflower, broccoli, and radishes. While these goitrogens don't cause thyroid disease, they can aggravate a pre-existing thyroid problem. Even potatoes can contain a natural toxicant, solanine. Solanine is a narcotic-like substance found in the sprouts of the potato and in the green layer right under the skin itself. While toxic in large amounts, one would again need to ingest large quantities of potatoes for adverse effects. These adverse effects can include GI issues as well as neurological disorders. Cooking does not destroy solanine. However, by peeling the potato, the solanine will be removed. Production of this particular toxic compound will increase if the potato is exposed to light or if it's kept in a very cold or a fairly warm environment. Pesticides help ensure the survival of crops and are used to control insects, weeds, as well as fungi. Because pesticide residues may remain on foods we consume, safety is certainly a concern. Health concerns are greatest in those who have weakened immune systems, the elderly, as well as children, especially during important periods of growth. Both the FDA and EPA are involved in setting tolerance levels or keeping use within safe limits. Monitoring of imported foods is also conducted by these agencies. Violations of residue limits typically appears in about 13% of all foods imported. Despite the monitoring by the EPA and FDA, consumers still worry about pesticide exposure. There are steps that one can take to reduce this particular exposure, and these include trimming the fat from meat, removing the skin from poultry and fish. Pesticide residues are often fat soluble, so they will tend to be concentrated in these particular areas. Select produce that is intact without any holes in the skin where pesticides may actually enter. Wash produce with a scrub brush to dislodge pesticide residue. Discard the outer leaves of leafy vegetables where pesticides are often concentrated. Peel waxed fruits and vegetables such as cucumbers and apples. The wax applied will actually seal in the pesticide residue, making it much more difficult to remove. Eat a variety of food. This will minimize exposure to any one pesticide. And then also consider buying certified organic food, which will also reduce pesticide exposure. Some produce has been identified as having higher amounts of pesticide residue than others, and these may be the ones to consider selecting organic versions of. Those which tend to be higher in residue levels include apples, strawberries, grapes, celery, and peaches, while produce such as kiwi, grapefruit, cantaloupe, sweet potatoes, and mushrooms tend to be on the lower side. Another area the FDA monitors is the use and safety of food additives. Food additives are substances not normally consumed as foods, but added to foods either intentionally or unintentionally. We'll first take a look at intentional food additives, which are typically used to improve or enhance the taste, quality, and appearance of food. Antimicrobial agents are intentional food additives, which are primarily used as preservatives to keep food from spoiling. Salt and sugar are the most commonly used antimicrobial agents. They can hold onto water, making it therefore unavailable for microbes to be able to use for their own purposes. Nitrites and nitrates are chemicals used to preserve color, enhance flavor, as well as inhibit bacterial growth. However, nitrites are controversial because they can be converted to nitrosamines, which are a potential carcinogen in the human body. Another intentional food additive is the bacteriophages. These are a mixture of viruses which have been designed to destroy bacteria that can cause foodborne illnesses. They are often used in processed meat as well as poultry products. If it states on a label, an ingredient list, that bacteriophages are present, the term bacteriophage preparation will be used. Another way food can spoil is by exposure to oxygen or by oxidation. Antioxidants are therefore used to prevent such damage. When oil becomes rancid, developing an off flavor or smell, or a cut apple or potato turns brown, oxidation is occurring. We previously discussed the roles of vitamin C and vitamin E as powerful antioxidants within the body, protecting us from free radicals. They are also added to foods to protect against the oxidation process. BHA and BHT are chemicals often used in baked goods and snack foods, as well as in some cosmetics. However, they have been identified as potential hormone disruptors as well as possible carcinogens by the World Health Organization. Sulfites are salts which contain sulfur, also used as antioxidants. They are commonly added to processed food, wine, medications, dried fruit, as well as fresh grapes. Because of a small population experiencing what's known as sulfite sensitivity and then possible adverse reactions, the presence of sulfites must be specifically noted on the food label. Additionally, the FDA prohibits use of sulfites in foods which are high in thiamine. This is due to sulfites destroying this particular B vitamin. Coloring agents are also intentional additives. Only a few artificial colors may be used in food due to safety concerns which have occurred through much research. Many coloring agents are now derived from natural pigments found in foods, especially plants. Some examples include carotenoids, which are found in fruits and vegetables, added to provide a yellow or orange color. Caramel, which is created from heating sugar, is used to provide a brownish color to certain foods. Flavors and flavor enhancers are among the most common intentional food additives. Natural flavors include spices, herbs, essential oils, fruits, as well as fruit juices. Artificial sweeteners such as saccharin, aspartame, sucralose are added frequently. Flavor enhancers such as MSG or monosodium glutamate are routinely added to Asian foods, canned vegetables, soups, as well as processed meats. As with sulfites, however, some people have a sensitivity which may cause adverse reactions. For this reason, it must be specifically stated on a food label if MSG is present. Nutrients are also added intentionally, and they are used to fortify or maintain nutritional adequacy of foods. Back in Chapter 2, we discussed the terms enrichment and fortification in relation to nutrients being added. Common nutrient additives include thiamine, niacin, riboflavin, folate, and iron being added to grain products, iodine being added to salt, vitamins A and D added to milk, and vitamin C and calcium being added to fruit drinks as well as juices. Now we'll move on to unintentional additives, also referred to as indirect or incidental. These find their way into food during harvesting, production, processing, storage, or packaging. We'll first address the packaging issue. The FDA ensures the safety of food packaging and evaluates whether materials may migrate into foods. These materials include coatings, can interiors, plastic, paper, as well as sealants. Due to the possibility of packaging components migrating into food when heated, especially greater than 500 degrees Fahrenheit, only packaging noted as being appropriate for oven or microwave should be used. Avoid reheating foods in plastic take-home or styrofoam containers due to the possibility of migration of chemicals. Use plastic wrap noted specifically as microwave safe. If covering food in the microwave, avoid having it touch the food when reheating, again, to avoid the possibility of chemical migration. To cover food for reheating, wax paper is a better option. Only use glass or ceramic bowls or plates which are labeled as microwave or oven safe. Tiny air bubbles in glass may expand when heated, causing breakage. Some glazes on ceramics may be toxic and migrate into food at high temperatures. A chemical known as bisphenol A or BPA can also be an issue. It can leach from hard plastic bottles as well as can coatings. BPA has been identified as an endocrine disruptor, which interferes with the natural hormone production as well as function. Look for plastic in cans labeled as BPA-free. You can also check recycle codes for safety. If a number 3 or 7 is present, the container is made with BPA. If there is a number 6 present, this indicates polystyrene, which also raises safety concerns. Acrylamide was first introduced back in Chapter 18 as a possible cancer initiator. It's formed when high carbohydrate foods, which also contain the amino acid asparagine, are heated at high temperatures, as what occurs especially with the frying process. One specific food which falls under this category are potatoes. Acrylamide has been found in French fries and potato chips. Besides being linked with cancer, it may also cause nerve damage in humans. Methylene chloride is a common chemical used to decaffeinate coffee. In the process, traces of methylene chloride may be present in the coffee itself. Methylene chloride has been identified as a potential carcinogen. Consumers concerned about these residues, which may be left in the coffee, can look for products which are decaffeinated in other ways, such as being steamed or water processed. However, manufacturers are not required to list the type of decaffeination process used, so consumers often have to contact the manufacturer directly for such information. Hormones are a bit different than other indirect or incidental additives in that their use is intentional, but their presence in a final food product is not. The FDA has approved 12 hormones for use in animals, and the USDA, the U.S. Department of Agriculture, has established limits for residues in meat products. One common hormone is BGH, or bovine growth hormone. All cows naturally make this hormone, but when given in higher doses, it produces leaner meat as well as dairy cows produce more milk. The FDA claims that BGH absorption does not occur in humans, that it's digested by enzymes in the GI tract and also denatured by heating. Consumers, however, still have concerns not only for BGH but hormone use in general. While BGH has not been identified as such, other hormones have been designated as being potential endocrine disruptors. Like hormones, antibiotics are also intentionally given to animals, and residues may remain in meat as well as milk. When consumed, antibiotic residues then are transferred to humans. To minimize these residues, the FDA requires a specific time between when medication is given and when slaughter occurs. This allows for drug metabolism as well as adequate excretion. Antibiotic resistance certainly has become an issue. As bacteria continuously exposed to antibiotics adapt, they lose their sensitivity to the drug itself. The resulting antibiotic-resistant bacteria then can cause severe infections that do not respond to treatment in both animals and humans. Food safety is not the only issue when it comes to potential substances being present which may affect health. There are also water concerns. Water may contain microorganisms, environmental contaminants, pesticide residues, as well as additives. It's the responsibility of the EPA to monitor our public water systems. As alternatives, however, consumers may turn to bottled water or in-home treatment systems. Drinking water comes from two sources, surface water and groundwater. Most major cities obtain their drinking water from surface water, which includes lakes, rivers, and reservoirs. Surface water is easily contaminated from acid rain, runoff from highways and urban areas, pesticide runoff from farms, as well as industrial waste. Surface water, however, is more easily cleansed by exposure to fresh rain, aeration, sunlight, plants, and beneficial microorganisms. Groundwater is water found in underground aquifers, which are rock formations that contain usable water. People who live in rural areas rely more so on groundwater, which is pumped by wells. Groundwater is contaminated more slowly, but also more permanently. This is due to the lack of aeration, sunlight, plants, as well as those beneficial microorganisms. Groundwater is also very susceptible to contamination from hazardous waste sites, dumps, landfills, underground tanks, which may have been storing gas or other chemicals, as well as improperly discarded household chemicals and solvents. The EPA and local water companies regulate public water systems. These systems treat water to remove contaminants that are above acceptable levels. Chlorine is often added to kill bacteria. However, there is some concern due to the possible association with bladder cancer. Dioxins are a chemical produced by chlorine, which may also contaminate and harm the environment. Minerals are allowed within certain levels, but even these levels may alter the taste or odor of the water, as well as lead to hard water buildup. Out of concern of using public water, people may choose home water treatment systems. The first step is to determine the quality of water from a reputable tester, and this may include state or county health departments or a certified lab. There are different methods of water treatment: carbon filters, reverse osmosis, distillation. They all have specific contaminants or minerals that they will remove. Consumers may also choose to use bottled water as their drinking source. Whereas the EPA monitors the public water system, the FDA monitors bottled water. If you check the label on the bottle, the source of the water must be noted. Approximately 75% of bottled water comes from protected groundwater. The water is usually treated with ozone gas or chlorine to disinfect it. Some are also treated to remove minerals. The remaining 25% of bottled water comes from public or municipal sources, which have been cleansed through carbon filtration. One of the main concerns, however, of the increased use of bottled water is the amount of plastic bottles that are ending up in our landfills. As we wrap up the topic of consumer concerns when it comes to food and water, there is one more area to address. Advances in science have led to the development of biotechnology, the use of biological systems or organisms to create or modify products. Foods produced through biotechnology have been on the market for greater than 25 years, but there are controversies associated with its use that we'll review. Overall, biotechnology offers opportunities to produce leaner meats, extend shelf lives, improve nutrient composition, and increase crop yields. This science can also help to decrease the use of pesticides, as well as help to overcome food shortages and to eliminate or reduce disease. However, there are also potential environmental and health risks associated with this science. For centuries, farmers have been using selective breeding to develop hybrid crops with desirable characteristics. One of the earliest examples with early farmers using this method were to change a corn plant into the large, full ears that we harvest today. This method of selective breeding, however, is slow and imprecise, involving combining the genes from two separate plants and merging them together. While farmers still use selective breeding, genetic engineering allows scientists to insert or modify the genes in an organism to produce a new trait or to change an existing trait. These advances have brought rapid and dramatic changes, not only to agriculture, but to food production in general. Foods produced through this method are referred to as GMOs, or genetically modified organisms. Here we can see the differences in the processes of selective breeding and genetic engineering. With selective breeding, genes from two varieties within the same species are used to produce a hybrid with specific characteristics. The desired gene cannot be isolated. It is transferred along with other genes. This process then may be long until the desired hybrid is created. Genetic engineering, however, allows for that one specific gene to be transferred, resulting in immediate creation of a new product with the desired characteristics. Whereas selective breeding involves combining genes within the same species, genetic engineering allows for genes from different species to be merged together. Proponents of genetic engineering note the following benefits of using this biotechnology. Extended shelf life. Produce can be genetically altered to delay ripening and extend shelf life. This in turn leads to less food waste. Improved nutrient composition. Instead of manufacturers adding nutrients to foods during processing, plants can be altered for biofortification. An example is rice having genes added from a combination of daffodils and bacteria to allow for the grain itself to synthesize beta-carotene, which consumed then is converted to vitamin A. This rice can be used to feed populations where vitamin A intake is inadequate. Efficient food processing will help to save time and money. Cows can be genetically modified to produce lactose-free milk. This takes away the step where milk itself is treated to break down lactose for those who are lactose intolerant. Efficient drug delivery. Using cloned animals and other organisms in the development of pharmaceuticals is termed biofarming. Goats have recently been genetically modified to produce milk which contains a vaccine against malaria. This takes out having to provide separate immunizations in areas where malaria is rampant. Genetically assisted agriculture. This has been shown to help increase crop yields, extend growing seasons, as well as decrease the use of pesticides. Currently, there are 8 genetically modified crops grown in the United States. Corn, squash, and papayas are directly available to consumers for purchase. Soybeans, canola, alfalfa, cotton, and sugar beets are available for commercial use and are often incorporated into both animal feed as well as processed foods. Despite scientific evidence, many scientists and consumers question the safety of genetic engineering or the creation of GMOs specifically. Often they are referred to as frankenfoods. Some potential issues to note include disruption of natural ecosystems as well as disruptions in the food chain, introduction of diseases, introductions of allergens as well as toxins, potential creation of biological weapons. Ethical dilemmas also come into play, especially with genes being transferred between species. The FDA has taken the position that foods produced through biotechnology and cloning are not substantially different from others and require no special testing, regulations, or labeling. For that reason, the FDA adds GMOs to the GRAS list, which includes foods or substances generally recognized as safe. Supporters of mandatory labeling for GMOs say it's the consumer's right to know. Opponents state that indicating the presence of GMOs in a food may cause consumers to believe the product's safety is unfairly questionable. To help consumers identify foods free of GMOs so they can make their own decisions, the USDA is developing a voluntary certification and labeling system.